What's happening, everybody? Back again here with another calculus video, and in this video we're going to discuss some applications of the intermediate value theorem. First thing we got to do is determine the two conditions in order for the intermediate value theorem to apply. So by now we should know that condition number one is that the function in hand has to be continuous on the closed interval. Oh, there's a squirrel on my outside ledge. Look at him go. The function has to be continuous on the closed interval that is specified in the problem. So in this case, it's from -2 to 1. The second thing that we have to show is that the y value in question, which is 5, we have to show that that is going to be between, hence intermediate, the y values at the endpoints. So let's start off by saying, number one, continuity. So part one is continuity, and I'm going to say that p of x is a product of an exponential function and a trigonometric function. So first of all, I spelled trigonometric wrong. Second of all, I don't want to call it trigonometric, I want to call it sinusoidal. Because if I call it trigonometric, it's going to include tangent, and that screws up my statement. So a sinusoidal, when I say sinusoidal, I mean anything that's a sine wave, so cosine or sine or any transformation thereof. So it's a product of an exponential and a sinusoidal. And since both are continuous everywhere, so is p of x. So what I'm saying here is that e to the x plus 2 is continuous everywhere, cosine of x is continuous everywhere. So if we multiply those two things together, we're not going to create any discontinuities. So the function's continuous everywhere. If it's continuous everywhere, it's continuous on the closed interval. So that's part one. So we're good there. Part two is to determine the values at the endpoints. So we have to plug in -2 and 1 and see what happens. So p of -2 equals e to the -2 plus 2 times the cosine of -2. And then p of 1 equals e to the 1 plus 2, which is 3, times the cosine of 1. And now we have to determine what these equal. So we got e to the 0, which is 1. So this one's just cosine of -2. We've got to figure out what that equals. And then this one is e cubed times the cosine of 1. E cubed times the cosine of 1. So in order to find these two values that we're looking for, come on, we're going to go to our calculator. And remember now, we are dealing with a trigonometric function here. So our inputs have to be considered as radians. They're not specified as degrees anywhere, so we're going to consider these as radians. So over to my calculator, make sure I'm in radian mode. I am not. I got to switch that. Get out of here. See what I got to plug in. I got to plug in cosine of -2 and e cubed cosine of 1. So let's do that. Cosine of -2, enter, and then e cubed. You can find the e function with an exponent down here. Cube, make sure you press right to get out of the exponent. Cosine of 1, I think it was. And those are our two values. So our two values are -0.416 and 10.852, hopefully. 10.852, -0.416. Perfect. So we just found those two values. The next question is 5 between those? And it is. So I'm going to now say, therefore, the IVT is applicable because P of X is continuous on -2 to 1, and let's say P of -2 is less than 5, which is less than P of 1. So I've formally stated all the reasons that the intermediate value theorem applies. Since it applies, there has to be some value. There is a guaranteed value, C, such that P of C equals 5, somewhere in between these two endpoints of P of -2 and P of 1. So now we got to find it. In order to find it, we're going to set the two parts of the equation equal to each other. So I want to know, where does e to the x plus 2 times cosine of x, where does this thing equal 5? And I don't know how to solve that algebraically, so I'm going to use my handy dandy calculator, which I'm going to preload with my equations and get back to you in 1 second. So I'm over here on my calculator and clearing out my old stuff. I've gone to y equals, and I've plugged in the left side of the equation, which is e to the x plus 2 times the cosine of x, and I've plugged in the right side of the equation, which is 5. I want to know, again, where does this equation equal 5? So the other thing I've done is I've gone to my window, I've changed the x values to match the interval at hand, which is -2 to 1, and I've changed the y values to match these two outputs, which were 10.852 and -0.416. So I went a little lower on this one. I did a y minimum of -1, and I went a little higher on this one. I did a y maximum of +11, and you can see that here in my window. And I just want to take a look at the graph and see what's what. So I hit graph, going to take a minute. One key to remember, if you ever want your graphs to go faster, you can change the resolution that it's graphing at. In other words, you can kind of tell it to skip a pixel or two here or there. I'll show you how to do that. So right now I want this to go faster next time I graph, so I don't want to go to mode, I want to go to window. And I want to go down to XRes. And I don't really know what this means, but I do know that if I change this to like a 3 and then hit graph, it's going to go faster. Look at that, that's much faster than the last time. So what do I got to do? I got to find where these students, where these two guys cross. So I'm going to go to second trace. I want to know where they intersect, which is option 5. And there's only one intersection on my screen, so if I just hit enter 3 times, 1, 2, 3, it should tell me that the intersection is at -0.334. And that is the value. So in our problem, C equals -0.334. We have just found the missing value that is guaranteed by the intermediate value theorem. That's it for now. I've shown you how to apply the IVT in a couple different ways, I think. At least one way for now. And I think I got another video where I'm going to talk a little more about it. Take it easy, y'all.